Welcome to Apparatus Service Department's Coating Technology Center, the CTC. Here we apply alloy and ceramic-based plasma-sprayed coatings to gas turbine combustion liners, shrouds, transition pieces, and other components from our gas turbine manufacturing organization. Because of our investments in computer-controlled equipment, CTC applied coatings are uniquely uniform in thickness, securely bonded, and are cosmetically excellent for customer presentation. In short, CTC makes a quality contribution to a quality component. Quality products come from quality processes. The CTC process operates with unerring consistency, part to part, batch to batch, week to week. The process system requalifies itself daily and polices itself in real time. And the process is extremely productive. It maintains painstaking quality while it meets even the toughest schedules. The Coating Technology Center is the brainchild of Gas Turbine and Apparatus Service Department, or ASD. The CTC concept started with the engineering groups at our Greenville and Schenectady gas turbine plants. Design engineers working with plasma spray experts from ASD helped formulate process parameters and qualifications for the plasma coating of gas turbine components. What emerged were new process specifications for gas turbine components, which is a huge step in improving the uniformity and quality of plasma coating. ASD's service-oriented manufacturing engineering experience made the tight specifications attainable by establishing the Coating Technology Center. The centerpiece is a robot programmed by CTC to achieve the exact results called for in each component's process specifications. Firing a plasma of gas turbine specified alloy or ceramic materials at 20,000 degrees Fahrenheit, it deposits coatings precisely, uniformly, productively, and consistently, cycle to cycle. By comparison, hand-applied coatings can't possibly attain the uniformity in thickness across the coated surface or be applied as productively. Quality checks precede production. Before components are run, we re-qualify the process, ensuring that the product meets gas turbine specifications. We run samples and conduct a bend test for bonding strength. For certain applications, we conduct a coating hardness test and then document the results for gas turbine manufacturing. Let's follow a transition piece through CTC. Upon arrival, it's checked in on computer. Only 2 paper forms follow this piece. Soon, CTC documentation will be paperless. We clean all components in a hot vapor degreaser, then meticulously mask them for grit blasting and later the plasma coating. We grit blast some components by hand. With others, we are automating the operation as we did for the combustion liner. We inspect each piece thoroughly after these operations. The component moves to the plasma spray cell. The transition piece is precisely positioned with respect to the robot. The robot and gun system has 6 axes. The cell is fed by preheated air and mixtures of argon or nitrogen and hydrogen gas. Since the plasma is released at 20,000 degrees, the gun is water-cooled. There's a separate computer program for each part number, and they are approved by gas turbine engineering. 2 computers and controls drive the system. The AR1000 operation unit controls the robot and turntable movement, and it controls the cell's air preparation system. The Advanced Thermal Coating System, we call it the ATS, controls the primary and secondary gas, plasma voltage and amperage, and coating materials flow. The ATS is programmed by a personal computer. Finally, a printout is made of every production run's parameters. The computer checks all system parameters, including primary gas type and flow rate, secondary gas type and its flow rate, current, voltage, and total power, materials hopper selection, carrier flow, hopper pressure, powder port, air jet, and nozzle. When the parameters meet their set points, the plasma coating begins. productivity gains are dramatic, especially considering the quality improvements. We coat shrouds 32 at a time versus 1 to 4 at a time by hand, and do it in less cycle time. The interiors of these transition pieces can't be coated manually with anywhere near the required uniformity of thickness. The human hand, encumbered with required protection and the standard plasma gun, won't fit. We achieve productivity gains of 50% on combustion liners, with quality superior to any semi-automatic or manual attempts in uniformity of coating, bonding strength, and repeatability. We reaffirm system accuracy and coating quality before each production run. The system also polices itself.
We program this very carefully. Right now, if any parameter that can affect the coating cycle falls outside its set point range, the system shuts off, and there's no override option. This ensures that the quality of the plasma coating process can't be compromised by system error.
We inspect every part we process. We also add touches like detailing, so a part's appearance is as good as its tested quality. When coated, the transition piece undergoes eddy current inspection.
This is a state-of-the-art application for eddy current, and we use it for testing uniformity and coating thickness at predetermined locations on this and other thermal barrier coated parts. Meanwhile, we continue to invest in equipment which will make us even more productive. This is our new Metco AR2000 robot, which we are now setting up and programming. The robot will be mated with a programmable work table so we can coat more intricate shapes and do it productively. We have a lot of confidence in our ability to serve GE's turbine manufacturing needs.
You've heard our opinion of apparatus service CTC capabilities. Here's another from Ken Bruning, Manager, Gas Turbine Manufacturing Operation.
We wanted to improve the way we went about providing plasma coating for our products. After using several outside vendors, we were looking for an opportunity to improve our cycle time, reduce unit cost, and provide better integration into the manufacturing process. In discussing the situation with John Mann and Gene Logan from Apparatus Services Southern Region, ASD came up with an innovative solution, not only from a technical standpoint, but one that just made good business sense for us. Our engineers and theirs took on the challenge and worked out the details. The rest you've seen today, and we hope others in the gas turbine community will learn more about this excellent facility.
What we do for our present GE customers, we can do for you. Put leading-edge levels of quality and productivity to work for you from a coating technology center 100% dedicated to plasma coating technology. Because CTC is part of a long tradition at GE's Apparatus Service Department, we understand the meaning of service. Call us now for more information on how we can work together.